Here we have another example for designing a counter. We want to design a counter to repeat the sequence of 6 states as given in the table. So we want to start from 0, go to 1, then from 1 we want to go to 2, from 2 the next state will be 4, then from 4 we want to go to 5, and from 5 we will go to 6, and finally from 6 we will go back to 0. So these will be the sequence of the numbers that we are going to count from 0 to 1, then from 1 to 2, 2 to 4, then 5, and then 6. So the counter that we will design will go through these numbers. In order to design the counter, we can form the state table. For the state table, we need to consider all the possible combination of the values for the A, B, and C as at the input side. So I think we are missing 0, 1, 1, which is 3, and 1, 1, 1, which stands for 7. So 3 and 7. We can either consider these as don't care cases, or we can tell to the system that we want to go to 0, for example, from any of these states. But we can start by considering them as the don't care cases. So in order to obtain the expression for DA, DB, and DC, we need to form the state table, and which we kind of have, but maybe not in the proper order, because usually we have 3 appearing here. But anyways, we can fill the Carnot map for each one of DA, DB, and DC. We have A, B, and C. If I do it for DA, I will refer to these columns so we have 0, 0, 1, X, and then we have 1, 1, 0, and X, if I'm not wrong. So then to obtain the expression, we can form these groups, and then DA will be given as A and not B, A not B, or not A and B, or in other terms it will be A, X, or B. We can find out the expression for DB and DC as well, referring to the same way using the Carnot maps, and over here you can see what are the expressions that we have obtained for DB and DC. You can do it on your own to practice. Then we can construct our circuit schematic, and then we can also check out, referring to this expressions, what will happen when we have 0, 1, 1 as the current state, or 1, 1, 1 as the current state. We just need to plug these values into the expressions that we have for DA, DB, and DC, and then we can determine the next state. Over here you can see how the circuit is constructed for our counter, with 3 D-type flip-flops which receive the input from the output of those gates according to the expressions that we have found. And here you see that if we start from, if for any reason we are in 0, 1, 1, or 3, in one clock pulse we will go to 1, 1, 0, and then we will continue with the main loop in it. Over here, if we start from 1, 1, 1 for any reason, in the next rising edge of the clock we will end up at 0, 1, 0, or 2, and then we will remain within the main loop, as you can see here.